This is Anthony Priscilla discussing expanding binomials with this college algebra class. Say binomial expansions. And you've already done, you've been expanding binomials for a long time in your algebra classes. If we had something like a plus b squared, you didn't just square the a and square the b, did you? How would we expand a plus b squared? You don't just square the a and square the b. Well, you're going to have to FOIL that out. Now, some of you can do this FOILing and expansion in your head. And you'd have a squared plus 2ab plus b squared. The natural question to ask is there a shorter way? I mean, it's pretty easy if there's just a square. Even if there were a cube, you would get this answer and then multiply by another a plus b. So it's going to start getting a little bit longer. But what if the exponent were 5, a 6, or 7? How could you expand it quickly without having to just start FOILing it out like that? Well, there's a couple of ways to do it, and the way we're going to discuss today is using something called Pascal's triangle. Pascal's triangle is a triangle, of course. Why would it be called Pascal's triangle if it weren't a triangle? It's a triangle made out of numbers. And each row of the triangle begins and ends with 1. The first row is just a 1. The second row of the triangle has 2 1s. The third row of the triangle, each row begins and ends with 1. Let's see, I'll put this in black. Begins and ends with 1. And it's going to have 3 numbers, and to get that middle number, the number that's in between them, you add the 2 numbers up above it. So I'm adding these 2 blue 1s to get a 2. Next row begins and ends with 1. Add the 2 numbers up above it. 3, 3. Begins and ends with 1. Add the 2, so it would be numbers up 4, 6, 4. Begins and ends with 1. So 5, 10, 10, 5, 1. This triangle goes on and on. Just for illustration purposes, maybe I'll make 2 more rows. 1, 6, 15, 20, 15, 6, 1. I'll make 1 more row now. Now follow how I'm getting these numbers. And let's see, what's the last row? I'll do it in the pink. Begins and ends with 1. But I said the last row. The last row I'm going to do 7, 21, 25, 25, 21, 7. And we can just put dot, dot, dot. Now, what are we going to do with this triangle? Well, on this triangle, you're going to use the row, let me see, to expand a plus b to the nth power. Use this row, use the row that has n as its second number. So we've already expanded a plus b squared. How would we expand a plus b, let's say, to the 6th power? with a plus b to the 6th b. Well, start off using the triangle. You locate the row that has 6 as its second number. Okay, so looking at the second numbers, this one right here. These numbers here are the binomial coefficients. What do I mean by that? Well, let me write them down. I'm going to write them down vertically. 1, 6, 15, 20, 15, 6, 1. These are the coefficients that you would have when you foil, if you started foiling and expanded all of that. Now, what about, sort of to imagine foiling it out, like when we foiled out a plus b squared, the first term we got was an a squared, the last term we got was a b squared. If we were foiling out a plus b to the 6th, ultimately the first term you'd get is a to the 6th. So coming up here, you're going to sort of write a to the 6th, take that first term, raise it to the 6th power, and then start decreasing the exponent. 3, 2, 1. Then do the same thing starting at the end. Take b to the 6th, put it there at the end, and then start decreasing the exponent. B to the 5th, b to the 4th, b to the 3rd, b to the 2nd, b to the 1st. And you'll see more why I'm writing it vertically like that, but the real answer, when you see it written in a book or somewhere, would be written out horizontally. A to the 6th plus 6a to the 5th b plus 15a to the 4th b squared plus 20a cubed b cubed plus 15a squared b to the 4th plus 6ab to the 5th plus b to the 6th. That's a pretty fast way of expanding something like that. Now, why am I suggesting, or why am I writing it out vertically? Sometimes students say, oh, I want to write out horizontally, just right off. Okay, that's fine. But sometimes this writing it out vertically like that will help you simplify stuff. For instance, let's try this one. Suppose we have to expand 2x minus 3y to the 4th. Oh, there it is. 2x minus 3y to the 4th. That's what I'm going to expand. You use the row that has 4 as its second number. So you write down 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Now, you begin to see how this can be a little messy. Take that first term, let's say the 2x, raise it to the 4th power, and then start decreasing the exponent. 3, 2, 1. Then take the second term. Now the second term, you can't just write 3y. That would be a positive 3y then. You have a negative 3y. Start at the end, decrease the exponent. 4, 3, 2, 1. Now you got to simplify this stuff. You begin to see why I like to set it up vertically. Let's see. This 2x to the 4th. Oh, can y'all see that? I mean, we don't need that triangle anymore. I'll just move this on up. the 2x to the fourth, 2 to the fourth, 2 times 2 times 2 times 2, that would be a 16x to the fourth. And here we have a pink 4 times 2 to the third. What's 2 to the third? Don't say 6. 2 times 2 times 2, that's a 8x cubed. And then a negative 3 y to the first would just be a negative 3y. So what are we going to have there? 4 times 8 times negative 3. Well, 4 times 8 would be 32 times a negative 3 and negative 96. X cubed y. Following my calculations here. Look on the next one. It's going to be a 6. Now, blue 2 squared would be a 4. Then x squared. And on the next one, the negative 3y squared, is there going to be a negative here once we're finished squaring it? Negative 3 times negative 3, that's going to be a positive 9y squared. So we have 6 times 4, which is 24, times 9, that's 216 x squared y squared. 4 times 2x times, oh, we're almost out of time, I know. Negative 3 cubed, negative 3 times negative 3 times negative 3. Is that going to be a positive or a negative? Negative, right. So I'll write it like this, times a negative 27y cubed. Jennifer, are you punching that into your calculator? What'd you get? It's another negative 216? Yeah, okay. Negative 216 xy cubed. And then finally, negative 3 to the fourth. Don't say negative 12. Negative 3 times negative 3 times negative 3 times negative 3. That's like 9 times 9, isn't it? That's going to be 81 y to the fourth. So what would this 2x minus 3y all raised to the fourth look like? If you wrote it out horizontal, here's the answer. It would be 16x to the fourth minus 96x cubed y plus 216x squared y squared, this is a y, minus 216xy cubed plus 81 y to the fourth. Well, we'll pick up and I'll actually do some problems from the homework the next time. Okay, I know we're out of time today, so I'll see y'all on, well, next class meeting. Okay, thanks. Bye-bye.